Okay, I thought I'd give a little bit of a 101 on regenerative braking in the EV. Electric motors have this one cool thing about them. They can also be generators. If they're wired correctly and designed correctly, they can be both a motor and a generator. Where this was first used, well, not first used, but 10, 12 years ago, probably more like 15, I guess, but we came out with hybrids. So manufacturers came up with something. They wanted an economy car that got better fuel economy. And the one thing automotive engineers knew was when you are driving your car at speed, say you're going 35 miles an hour, and you come up to a stop sign or a stoplight, you're going to have to put on the brakes. Okay? Now you could let off the throttle and let the car coast to a stop. That's probably going to get you a few swear words from other drivers. So you're probably not going to do that. But if we could set up a car that when you put on the brakes, instead of the brakes coming on first, when you first step on the pedal, it would turn a motor, which can be a generator, and it would turn it into a generator, and it would charge a battery in the car. It took the fuel economy and raised it, 10, 20%, depending on how you drive. It was finding a way to use energy that you were throwing away. When you step on your brakes, they're friction devices. Friction devices creates heat. Okay, the fuel burns, it's hot, it's changed over into rotating motion, and then to get rid of it, when you want to slow down and stop, you turn back into heat again, essentially throw it away. So the hybrids took advantage of this and used a motor generator assembly that could put that energy back. That does not mean your driving was free. It only increased your fuel economy a little bit. What happens when you move a car down the road, you've got rolling resistance, you've got wind resistance, and some mechanical resistance in the vehicle. And so it's not a panacea. Like I go up to 60 miles an hour and then I get off the freeway after driving 10 miles and use no energy at all. It doesn't work that way. You're still going to lose. But it made things more efficient. Well, when we started making EVs, they took advantage of this even more so. And they have what's called one-pedal driving, which is, I own a Chevy Bolt. I use the one-pedal driving all the time. All that is when you accelerate, it's normal. When you start to let off of the, quote, gas, it puts on the regenerative braking. And it can be very aggressive. On the Bolt is actually the best car I've driven for regenerative braking. It's really good. If you put it in D, it has light regenerative braking, kind of like an automatic transmission car would have when you let off the throttle. And it's regenerating then. By the way, electric cars do not have a compression slowdown. When you let off the throttle, the car doesn't really slow much unless you have regenerative braking. I built an electric car at one point, and that thing would coast forever. Internal combustion engines have tremendous frictions inside. They've got springs and all sorts of things in there that cause a lot of drag. But in this car, in D, it's kind of like an automatic transmission car. If I put it in L, it's very aggressive. You're kind of feathering the throttle to stop at the right time. And then there's a little paddle on the steering wheel that if you want more, you can pull that. You can also, when you step on, you can just use the brakes. And the first part of the brakes is regenerative. Ideally, one of these cars will never ever need a brake job. I have driven a Tesla Model 3, and it has fairly aggressive regenerative braking, but it doesn't stop completely. The Bolt does, and the Leaf also is pretty aggressive. Anyway, when you're using this, you'll see on the dashboard, and I'll show you in the Bolt. I've got the video going, and on the dashboard you can see there's a little battery thing there, and the little doohickey starts turning when you're using regenerative braking, and it's telling you how much you're using. In the little square there's a kilowatt thing, and if it's yellow, you're accelerating. If it's green, you're putting power back into the battery. Now this does make quite a bit of difference. It's a little different to drive, but it takes advantage of all the wasted energy that normally a gasoline-powered car would have. Let's look at a gasoline-powered car going up a hill. Okay, it's going to use a bunch of power going up the hill. Okay, when you go down the other side of the hill, it still uses power, it just doesn't use anywhere near as much. On the electric car, with regenerative braking, when you go up the hill, it's the same thing, using a whole bunch of power to get that thing up the hill. Then when you go down the hill, you get up to 90% of the energy that you used back. Now that's just for going up hills and back down again. But you can gain quite a bit with regenerative braking if you're using it in the high regen mode. I know the Model S Tesla, you actually have to step on the brake to get any regeneration at all, which is a little odd to me, but maybe they're just trying to make it more standard like everybody else's car. But regenerative braking is one of the high efficiency parts of an EV that make it one of the most efficient vehicles out there. Anyway, that's it on this one.